Dear students, welcome to a new video for the reporting course. Now we will begin chapter 2, which is hypothesis testing. First of all, we will define what is the statistical hypothesis. A statistical hypothesis is a conjecture about a population parameter. This conjecture or guessing may or may not be true. So there are two types of statistical hypotheses for each situation: the null hypothesis and the alternative hypothesis. First, we will define the null hypothesis, which is symbolized by capital H and subscript node like this. Here, okay, here. This is the sample for the null hypothesis. This is the statistical hypothesis that states there is no difference between the parameter and the specific value, or there is no difference between two parameters. And the alternative hypothesis, symbolized by H1 here like this, is a statistical hypothesis that states the existence of a difference between the parameter and the specific value, or what states the difference between two parameters. Let's define or make an example from a real life. What is the difference between the null hypothesis and the alternative hypothesis? Now, when we buy, for example, a package of milk and the weight is almost 1 kilo or 1 liter. So we have a real weight stated on this package, but it may be less than 1 kilo or it may or maybe greater than 1 kilo. So we know, and maybe it's exactly equals 1 kilo. To know the exact time, we make an inspection by taking a sample from the whole population and make a hypothesis testing about the weight for these packages, and then get the answer depending on the hypothesis testing like this. So you may have two different hypotheses. The first, that the package is equal exactly 1 kilo, and this means there's no difference between the mean of the weight and a specific value which is equal to 1 kilo. So in this case, the null hypothesis is that our package, which is H node, may be the mean mu equal to 1 kilogram. So this is the null hypothesis. Note that the null hypothesis always has the value which is no difference. We have a no difference meaning for the mean. So the mean is not equal to 1 kilo. So we have the parameter of us is mu equal 1. And your conjectures about this weight may be greater than or less than, or maybe it's not equal to exactly 1 kilo. So the alternative hypothesis here, which is H1, is mu may be not equal to 1 kilo, or mu greater than 1 kilo, or mu is less than 1 kilo. So the alternative hypothesis may be one of the three cases or three forms. So we have always the null hypothesis, which is there is no difference, okay, between the parameter and a specific value, or there is no difference between two values, for example, mu1 and mu2. So for all the time we have equal signs, or most of the times we have equal sign in the null hypothesis, and in the alternative hypothesis we have the unequal sign, greater than sign, or less than. Let's continue for the definitions of this part. We have now three situations to more identifying the two definitions. In situation 1, A medical research is interested in finding whether a new medication will have an undesirable side effects. The research is practically concerned with the pulse rates of the patients who take medication. Will the pulse rate increase, decrease, or remain unchanged? So we have here case, a new medicine, and we already want to know if this medicine have a side effect or the pulse rate or not. If this may increase pulse rate or decrease the pulse rate or remain unchanged after a patient takes medicine. So, since the researchers know that the mean pulse rate for the population under the study is 82 beats per minute, the hypothesis for this situation is states the two hypotheses, which is the first is the null hypothesis and the second is the alternative hypothesis. Here we know all in the medical population that the pulse rate is always equal to the mean value is equal to 82. So the null hypothesis here will be mu equal to 82. And here the alternative hypothesis here H1 is mu equal not equal to 82. We have an unequal sign from the given in this situation that he don't know really if it's increase or decrease or remain unchanged. So it's the value, it may be not equal to 82, but and we don't know in the positive direction or negative direction or what is the alternative values. So here we have a situation with mu not equal to 82. Another situation all here it is a comment of this situation or comment for the solution A that the null hypothesis specified that the mean will remain unchanged and the alternative hypothesis states that this will be a difference. This difference may be increase, decrease, or remain unchanged and the test is called two-tail test. Why we said this is a two-tail test? Because the H1 have an unequal sign. Here mu not equal to 82. So when we have an unequal sign, the test is called two-tail test. This term will be formally defined later in this section. Since the possible side effects of the medicine couldn't be raises lower raises or lower the pulse rate, so we take it a total test with maybe less than or another situation P is a chemist invents an additive to increase the life of automobile battery. If the mean lifetime of the automobile battery without the additive is 36 months, then here the hypotheses are we have two hypotheses, which is T0 and H1. H1 is mu equal to 36 and H1 mu is greater than 36. Why we here in the H1 or the alternative hypothesis we take the greater than sign? Because from the situation we already get an increase here the rate or the battery mean lifetime is 36 months as usual, but the chemist invents a new one which is maybe increased. So we have the null hypothesis, which is the battery lifetime or mean battery lifetime as usual, which is 36, and we have an alternative hypothesis, which is mu greater than 36. So in this situation, the chemists are interested only in increasing the lifetime of the batteries, and her alternative hypothesis is that the mean is maybe greater than. So we have only one tail, which is the right tail. Why it's a right tail? Because it's a greater than sign and we have a positive values, so the greater than sign, so with the we interest only in an increasing, so this is called a right-tailed cut and also tilde, and also is called a one-tail test. One-tail test. This is for situation number P. Let's move to another situation, which is situation number D. C. A contractor wishes to lower heating bills by using a special type of installation in houses. The average of the monthly heating bill is $78. Her hypothesis about the heating cost with the use of installations are: each node is equal to mu equal to $78 and per month, and H1 is mu less than 78. Note that we set the alternative hypothesis depending on what is given in our situation. Here, the contractor is interested only lowering the heating cost. I mean that the heating cost average per month is as usual equal to 78. So mu is equal to 78. But we have another wishing for lower heating bill. So we have a left tail test with mu less than 78. Since the contractor is interested on only lowering the heating cost, we stated the hypothesis as one tail test with a left tail test. Here it means the left tail test because it's less than signs in the alternative hypothesis. Here, the researchers must translate the claim from the words into a mathematical form for each node and H1. By using this table, we can translate the situations given or the examples or exercises given to know or to decide the type of the test with its right tail test or left tail test or two tail test, and this is for the this equal sign for the null hypothesis. Let's here begin with greater than sign. If you have in your situation these words, which is greater than, it's above, higher than, longer than, bigger than, or increased, this means that you will get the H1 as greater than sign. And if you have in the situation or the exercise given is less than, is below, is greater than, is lower than, shorter than, and smaller than, decreased or reduced, you should get in the H1 and less than less than sign. And if you have in the situation is not equal to or difference from or hasn't changed from or not the same as, this means the alternative hypothesis is have a no a less not equal sign. If you have in here for the each node, we have it's equal to the same as and has not changed from, and this is the same as. So this is each node sign equal with equal sign. Of course, you know that in the first greater than and less than, it's one tailed test, one tailed test. Okay, and here greater than it's right tailed, and in the less than sign is the left tailed. And for the H1, when it's have an equal sign, it's a two-tailed test. Here, let's practice more in this point. For number A researcher thinks that the experimented mothers will use vitamins pill. The birth weight of the babies will increase. The average birth weight of the population is 8.68 pounds. Here, if the moms take vitamins, maybe at a pregnant time, maybe the babies increase. It's maybe so. The weight average is as usual is 8.6. So we have each node equal mu equal to 8.6, but it's maybe increased. So we have increase which indicate for the alternative hypothesis mu greater than. And this is a one-tailed test and right-tailed test. Right-tailed test. Another example, an engineer hypothesis that the mean number of defects can be decreased in manufacturing process of compact discs by using robots instead of humans for certain tasks. The mean number of defective discs per 1000 is 18. So they here an engineer and want to decrease the defects in the process of manufacturing by using a robot. So the mean number of defects may be 18, but he wishes or he says that his robot may decrease here a key word here, which is decrease, may decrease the defects to less than 18. So the mu here is less than sign, so it's a one-tailed test, but it's a left-tailed test. Another example, number C, pathological feels that playing soft music during the test will change the results of the test. That it's not sure whether the grades will be higher or lower. In the past, the mean scores was 73. So the mean as usual was 73, which is each node, and each one in the scale in this case will be mu not equal to 73. This is because we aren't sure that's higher or lower in of the 73. So now we will state each node and each one as the first step in the hypothesis testing depending on the given statements in our situations. Also, we can set the claim as hypothesis like this in this table. It's just a guidance for you to use the samples here or inequality sample in your hypothesis to set each node and each one as follows. When you have larger or more than, greater than, and h1, smaller than h1 here, no more than, which is less than or equal, and at least is greater than or equal in each node, has increased, is greater than, is the difference change is equal, not equal, and no difference is equal sign. Now, let's move to another very important definition, which is a statistical test. The statistical test uses the data obtained from a sample to make a decision about whether the null hypothesis should be rejected. And the numerical value obtained from a statistical test is called a test value. So we have two main definitions in this part, which is a statistical test and a statistical value. Please concern about what is different between the statistical test and test about it's maybe a point of test for you or a question for you. What is the test value? The test value is a numerical value that's obtained from a statistical test. I mean the rule that we have for each test. And the statistical test uses the data obtained from a sample, okay, to make a decision about whether the null hypothesis should be rejected. But all the time we concerned about the null hypothesis, whether the null hypothesis should be rejected. Another very important definition in the hypothesis testing process, which is the level of significance. The level of significance is the maximum probability of committing type 1 error. The probability is simplified by alpha. So the level of significance is alpha here, this simple, and it's called a probability P for type I error or type 1 error. The statisticians generally agreed for using three levels, 0.1 for levels of significance, 0.05 and 0.01. This means we have a type 1 error, which is committing type 1 error, rejecting the null hypothesis when it's true. So the null hypothesis, which is 0.1, where this means 10% the chance of rejecting the true hypothesis. There is a chance of 5% chance of rejecting a null hypothesis. This means the level of significance. Again, the level of significance represents a type 1 error, and type 1 error means that rejecting a true hypothesis and rejecting the null hypothesis when it's true. Okay, so it may take 10% or 5% or 1%. After a significance level is chosen, depending on the survey or the researcher, the critical value is selected from a table which is appropriate. We have a table for these critical values like Z table, chi-square table, and T table, many tables that we can get the critical value. Our critical value depending on the significance level chosen, I mean alpha. So from this point, we have a very, very important definition, which is a critical value. The critical value, which is the value separates the critical region from the non-critical region. I mean, if we have a normal curve like this, so we have a critical value, and here it's 0, and critical value here. So this critical value is separate all our region here from accepted and rejected. And we can say that here the critical region, this is a rejected region, and here it is this region is a accepted region. So these critical values that obtained from the Z table or T table or chi-square table, whatever they test here, this critical value can separate this region from non-critical and the critical. The critical region, which is the rejected region, is the range of the test, is the values of the test value that indicates that there is significant difference. Here is the significance. Here is the critical region or the rejection region. Any point here is to be rejected. So this values is a significance difference and null hypothesis should be rejected. But here, any values here in the side, green side, it is the range of values that the test value that indicates that the difference was probably due to the chance and the null hypothesis shouldn't be rejected, which is non-critical region or non-rejected regions. Maybe the difference, but this difference was probably due to chance. Okay, this is all for our definitions for the null hypothesis testing, and in the other video we will take a more practice in the situations and in the exercises and the problems solved by using hypothesis testing. Please concentrate on the definitions and what's meant by each definition to get a clearly meaning about the hypothesis testing, and so you can solve any problem by using hypothesis testing easily. Thank you for listening.